You know that feeling when you ask an AI a question and it gives you this super confident answer that's just completely wrong? Yeah, it's a huge problem. But what if we could teach an AI not just to think, but to actually do stuff, to go out and check its facts, to reason more like we do? Well, that's exactly what we're talking about today. We're diving into a really cool new paradigm called ReAct, which is designed to do just that.
Okay, so here's the game plan. First, we'll tackle this hallucination problem head on. Then we'll look at the two old school ways of building AI, what I call the thinkers versus the doers. After that, we'll see how ReAct is this amazing breakthrough that just smashes them together. We'll walk through a real example, see how it holds up in some tough tests, and then wrap up by asking the big question: is this finally the key to building an AI we can actually trust? All right, let's dive right in with the big problem. Even the smartest large language models, LLMs, they have this nasty habit of just making stuff up. It's called hallucination, and honestly, it's the one thing that makes these incredibly powerful tools feel so fundamentally unreliable.
I mean, it's a wild paradox, right? These AIs can compose music, they can write code, but then they'll turn around and tell you with 100% confidence that the sky is green. So why? Well, it's because they're basically living in a black box, totally disconnected from the real world. They're not thinking, they're just predicting the next most likely word based on patterns they've seen. They're not actually checking if any of it is true. And that right there, that's the trust gap. That's why you can't just hand over a critical, fact-based task to them and walk away.
And this leads us right to this core conflict, this fork in the road that's been around in AI development for a while. See, for the longest time, researchers basically built two kinds of AIs. You had models that were great at reasoning inside their own minds, and you had models that were great at taking actions out in the world. The game-changing idea we're looking at today is what happens when you just do both at the same time? Okay, so let's break down these two different paths. On one side, you've got your thinkers, and on the other, your doers. And for ages, these two camps, these two types of AI, they pretty much stayed in their own lanes. So check out this trade-off. It's really the heart of the problem. Your thinker models, these are the ones that use things like chain of thought. They're awesome at planning, at breaking a complex problem down into steps. But here's the fatal flaw. They can hallucinate a fact right at the beginning and then build a perfectly logical but completely wrong argument on top of that shaky foundation. It makes them super unreliable, even dangerous. Then you have the doer models. They're much more grounded in reality because they can actually do things, like search a database or check a website. The problem is, without that high-level thinking, they're kind of clumsy. They get stuck easily, they act inefficiently, and they just fall apart when faced with a complex problem. So you see, neither approach is the whole solution. And this is where ReAct steps onto the scene. It's such an elegant idea. Instead of picking a side, it just combines the two, creating this incredible synergy. It's not a thinker or a doer, it's a thinker and a doer. So what is ReAct really? At its core, it's a new way of prompting an LLM to generate two things: a reasoning trace, basically a thought, and then a task-specific action. And the magic word here is interleaved. It thinks, then it acts. It sees what happened, and that observation informs its next thought. This simple little loop, think, act, observe, think, is what makes the whole thing so powerful. And, just as important, it makes the AI's process totally transparent to us.
The paper uses this perfect analogy: cooking. I mean, think about it. This is exactly how our own brains work, right? You have a goal, make dinner. You form a thought. Okay, I need the pepper shaker. That thought leads to an action. You go open a cabinet. Then you make an observation. Nope, not in here. That new piece of info forces you to update your plan, to form a new thought. All right, let me check the countertop next. That simple cycle, think, act, observe, and then think again, that's the soul of ReAct. Okay, so enough with the analogies. Let's look at a real-world example straight from the research paper. This is awesome because it shows exactly how ReAct can solve a tricky question that trips up other AIs. So here's the question they gave the AI. Aside from the Apple remote, what other device can control the program it was originally designed to interact with? Now, a normal AI might just flail around here, but watch what ReAct does. It starts by generating its very first thought. It's basically thinking out loud, creating a clear, actionable plan. Okay, first I need to figure out what program the Apple remote was originally designed for. So based on that thought, it takes its first action. It does a search for Apple remote, probably using something like a Wikipedia API. And boom, It gets an observation back, a little snippet of text. And right there in that text is the golden ticket. The name of the program is Front Row. This isn't a guess. This is a new, externally verified fact.
And here comes the magic moment. The AI takes that observation, that new fact, and uses it to generate its next thought. It's updating its plan on the fly. It realizes, okay, front row is the key here. Now I need to search for front row and see what else can control it. You're literally watching that think-act loop in real time. It's a dynamic, grounded way of reasoning.
And what's the end result? Well, a traditional reason-only model just flat out gets this wrong. It hallucinates, it guesses that maybe an iBot can control it. But ReAct, it just follows its own logical trail, searches for front row, and finds the correct and kind of obscure answer, keyboard function keys. It got it right because it never let its reasoning float away from the facts.
Okay, that is a seriously cool example. But does it work consistently? How does it perform at scale? Let's switch gears and look at the hard numbers, because this is where the case for ReAct gets really, really strong. Okay, so they tested this in a really complex text-based game called AlfWorld. And the results, they're kind of staggering. ReAct hits a 71% success rate. I mean, that absolutely demolishes the act-only model, which just gets stuck all the time. And get this, it even destroys the previous state-of-the-art model called Butler, which could only manage 37%. It's not even close. Just adding that simple thinking layer makes all the difference in the world.
But honestly, this next slide, for me, this is the real bombshell. This is the most critical piece of evidence. They did a failure analysis on a tough question answering benchmark. For the old school reason-only model, a whopping 56% of its failures were because it just made stuff up, hallucination. And for ReAct, take a guess, 0%. Not one failure was due to hallucination. It completely eliminates that failure mode, because every thought has to be backed up by a real-world action. Now, it can still make a mistake in its reasoning, sure, but it stops just inventing facts out of thin air.
And all of this, it leads to something way bigger than just getting a better score on a benchmark. It's about interpretability. It's about control. It's about building an AI that's safer and, frankly, that we can actually work with.
Because we can literally read the AI's thought process as it happens, we can finally understand why it's doing what it's doing. And even better, if it's about to make a mistake, we can step in and help. Check out this example. The AI makes a bad guess, a little hallucination, thinking a second keychain must be in the same place as the first one. It goes to look, and it gets stuck. But because we can see its thoughts, a human can just jump in and edit that one line of text, giving it a better hint, like, hey, maybe check the dresser instead. And the AI instantly takes that correction, updates its whole plan, and goes on to solve the task. It's incredible. This makes the AI so much more controllable and collaborative.
So let's just wrap this all up. What are the big takeaways here? First, ReAct brilliantly combines thinking and doing in this simple, powerful loop. That synergy grounds the AI in the real world, which basically kills factual hallucinations. Third, because we can follow along with its thought process, the whole thing becomes interpretable. We can see how it's working. And that is the foundation for building AI that we can finally start to trust and actually control. And that leaves us with this one final, really provocative thought. For decades, AI has been this mysterious black box, right? You put a question in, you get an answer out, but you have no idea what happened in between. ReAct cracks that box open. It literally shows its work, step by step. So the question is, if an AI can show us its work, if we can correct it when it's wrong, can we finally start to trust it? Maybe this isn't just about building a smarter tool, but about building a real partner.